So it is Biot-Savart law. It is similar to Coulomb's law. Exactly similar to Coulomb's law. We know Coulomb's law is the force between the two charged particles Q1 and Q2 separated by a distance r. It is equal to F equals to K Q1 Q2 by R square, where K it represents the medium. Okay, the force between the charges kept in a particular medium. Okay, but in this particular case, here the charge is the source for the force. Otherwise, if you go for the field, so instead of force, if you go for field, E equals to KQ by R square. Okay, this is also Coulomb's law. The thing is, the source for the field is a charge. Here the electric field is electric field. Similarly, in case of magnetic field, there must be a source. So similar kind of formula we have. Okay, for magnetic field B, we have a separate formula. We will see one by one. Okay, consider a current carrying wire or current carrying conductor. It carries a current I. Okay, it has a current. The length of the conductor is L. That entire length of the conductor. Suppose if it is X and Y, it is extended or infinitely long. X and Y. Okay, you just take a small segment. Okay, small segment in this entire length. That is DL. Okay, DL carries current I. Okay, actually DL is a vector quantity. If it is multiplied with I, no, the DL is a vector quantity. IDL, we call it as current element. Okay. IDL, it is a current element. It is the source of the magnetic field. Okay, suppose if I have a point P out somewhere outside, point P, at this particular point, the magnetic field due to this current element is given by the distance between the current element and the point P is R vector. It is a position vector, and the angle between the current element and the position vector, no, it is theta. So it is also essential. But in case of Coulomb's law, there is no relation between angle directly given. But Biot-Savart law, we have an angle dependence also. So therefore, the magnetic field at this particular point, for this is a very small current element. No, therefore, instead of writing B, we have to go for dB. So the dB, it is depending on the current, amount of current passing through the conductor, and dB, it is again depending on the length of the wire or length of the wire segment, and dB, it is again proportional to the sine of angle theta between the DL and R vector, and also dB is inversely proportional to R square. So this is Biot-Savart law. So Biot-Savart law is the magnetic field strength is directly proportional to I, dl, and sine theta, and inversely proportional to R square. That's all. So combining all the quantities, we will get dB is proportional to I, dl, sine theta divided by R square. So cancelling this proportionality symbol, we have to go for a constant K. Here also K, IDL sine theta divided by R square. Here K is mu naught divided by 4 pi. Mu naught divided by 4 pi IDL sine theta divided by R square. Here mu naught is permeability of the medium. Sorry, permeability of free space. we studied permittivity. Here it is K, here it is equal to 1 by 4 pi epsilon naught. Here it is permittivity. In case of magnetism, it is permeability. So both represent the same nature of the medium. The value mu naught is equal to 4 pi 10 power minus 7. We will discuss about the unit of mu naught later, a little bit later. We'll come to this particular quantity later. You just know the mean value. Value is 4 pi 10 power minus 7. And writing this equation in vector form, dB vector equals to mu naught by 4 pi I dl cross n cap divided by or r cap. So you may go for r cap. Not r vector, it is r cap divided by r square. R dl cross r cap. Otherwise, if you want to write as vector in the numerator, dB vector equals to mu naught by 4 pi I dl vector cross r vector divided by r power 3. This is because of the rule cross product. Sorry, this one unit vector formula. Unit vector, we know r cap equal to r vector divided by r. This one relationship you should remember. A cap is equal to a vector divided by a. You might have studied vector class. The same principle if you use replacing r cap is equal to r vector divided by r. Therefore, the power of the denominator it is increased by 1. So be careful with the formulas. Okay, these two formulas are same, but the difference is here the numerator is vector quantity. Here it is not exactly a vector. It is a unit vector, not a vector. Unit vector. Okay, and this particular case, the direction is it is into the plane of paper. For this particular point, the magnetic field actually, if you you can go for the right hand curl rule. Right hand curl rule. The curled fingers will point in the direction of the magnetic field. Okay, if you hold the current carrying conductor in your hand, the thumb will represent the direction of current, and the curled finger will represent the direction of the magnetic field. At particular point P, the curled finger will point into the paper, not out of. Suppose if I take the point in this particular direction, if point P is in this direction, the curled fingers will come out of the plane of paper. Therefore, magnetic field it is in the opposite direction. If the P is taken in the reverse opposite side. So mostly they ask state Biot-Savart law. So Biot-Savart law statement is simply you don't need to write all the statement in words. You just go for this particular mathematical expression. These expressions are enough.
Okay, sir.
Okay, also you go for this scalar direct equation and then go for vector equation also. Okay, no need to write K and proportionality and all. It is not needed. You just jump to this equation directly.
Okay.
Next is Biot-Savart law. Using Biot-Savart law, we are going to derive the expression of magnetic field. Magnetic field due to circular coil on its axis. Circular coil on its axis. Okay, now suppose consider you have a circular coil. The current it is flowing in this direction. It is flowing in this direction, and we are going to find the magnetic field along the axis of the coil. Okay, it is along the axis of the coil. Okay, this one is the center of the circular coil, and the radius of the coil is, we'll go for the direction textbook image. Shall I use the equation of MTG or NCERT? What shall I use?
Sir, NCERT.
NCERT enough, right?
Yes, sir.
Okay, you may go for any derivation, no problem in choosing the derivation. Okay, but whatever it may be the notes, you just do it correctly. That is enough.
There you go, baby girl. Content clear in our house. Here you go, big girl.
Okay, they have taken in a different direction. In the direction of current, it is in the different direction. But whatever it may be, you will get the same answer, no problem. Answer will be the same. Okay, so this is a circular coil, and here the direction of current, it is in the opposite direction. Okay, as I have given in the opposite direction, no, I have mentioned the current is moving in the upward direction for this particular side, but here it is in the downward direction. But whatever it may be, the answer is the same, no problem. Okay, now come to the point. Okay, what we are taking, no, we are going to take a small current element in the upward direction. Okay, in the diameter, if you take this particular diameter in the y-axis, no, in the topmost point, you just take a small current element dl. Okay, current element dl. Okay, due to this current element dl, the current is flowing in this current element. Okay, due to this current element, we are getting a magnetic field at this point P. Okay, and you just connect the position vector from the current element, position vector from dl to the point P. Okay, and here it is our R. Okay, this is our R, and here the angle theta, no, the theta, if you draw a tangent in this direction, tangent in this particular direction, tangent, and the angle between the tangent and the R, it is equal to 90 degree in this case. Theta, it is 90 degree in this case. Okay, but in textbook, what they have taken, no, instead of phi, they have gone for theta. So you have to be very careful in this case. See, here they go for theta, but it is wrong methodology, because we already reserved theta for the angle between DL and R. Okay, angle between DL and R is theta. Okay, the symbol is already reserved for this particular quantity. But in textbook, what they have taken, no, the angle they have taken in the different manner. Okay, actually this theta, it is a wrong notation here. Either you can go for phi or some other different omega. Okay, I'll show the MTG textbook. Okay, if you see MTG textbook, no, or MTG or SLR or whatever it may be, they'll be going for different notation. Okay, you just see. They go for phi instead of theta. They have gone for phi. That is the only difference here. Okay,
sir.
whatever it may be, the answer will be the same. The only thing is we have to understand the question correctly. But be careful. Be careful while writing this question. Okay, if you are using the NCERT textbook, answer from the NCERT textbook, you have to be very careful. Okay.
Yes, sir.
Otherwise, you change this as phi instead of theta. You can go for phi. No problem. Okay.
Okay, sir.
Sorry. Now we write the equation dB equal to mu naught by 4 pi. They have taken, I think they directly give this as ideal sine 90 degree divided by r square. You understand?
Yes, sir.
Okay. Now I'll go for the solution. Okay. What they have taken now here, they have taken one particular current element. Actually, we have to integrate this particular equation over the length. Okay, over the length. Okay, over the length, we are going to integrate this particular one. But we have to go for a small change. Actually, we don't have only one particular quantity in this direction. We have n number of dls in the entire ring. Okay, it is not only one particular current element dl. We have n number of dls. That is why we are going to take the exactly opposite element in the diametrically opposite direction. Okay, if you take y-axis as a diameter, the
Yes,
exact
sir.
opposite point, no, the exact opposite point, the opposite diametrical position, we have taken another one dl. Okay, if you take this dl, no, we will get another one more magnetic field at this particular point. That
Yes,
magnetic
sir.
field will be perpendicular to this r vector. So suppose this is r vector now, this one is dB. So dB is actually perpendicular to rb. Here also r perpendicular to dB. Okay.
Yes, sir.
And we have to resolve the 2 dBs. Okay. If you resolve the dB, see dB, actually dB vector, it is in this particular plane. Okay, we are resolving dB into two components. Okay, I'll draw it separately. So this one dB and this one another dB. So the two dBs are resolved in horizontal and vertical axis. Okay, what happens now? This one is dB. They have taken angle theta here with an horizontal. So this one is dB cos theta, and here also it is dB cos theta. And this perpendicular components, no, these are all dB sin theta, dB sin theta and dB sin theta. See, the dB sin theta, dB sin theta, they are equal and opposite because we have taken dl as similar at these 2 points. The length of the vector, the dl vector, no, it is similar in both the cases. Also, the current through the coil, it is also the same. Therefore, the magnetic field at exactly in the same distance, no?
Yes, sir.
So the magnitude of the field is same. dB in the both the cases, dB is same. And similarly, the dB sin phi and dB sin phi both are same and opposite. They get cancelled.
Okay.
Okay, the magnetic field along the horizontal axis, no, they only get added. Therefore, dB sin theta cancelled. The components. Similarly, the components dB cos theta they get added. Therefore, the total magnetic field is equal to dB cos phi, cos theta. dB cos theta from 0 to 2 pi r. 0 to 2 pi r. Do you know why we have taken the limit from 0 to 2 pi r? Because we are integrating over the entire length here L equal to 2 pi r.
Oh, yes, sir.
Okay, now you insert the values. dB, we have already found dB 0 to 2 pi r. dB is
Mu naught.
mu naught by 4 pi I dl. You just ignore this one. R squared cos theta. And we have to go for the value of cos theta. Now, how to find cos theta? See this one, the entire angle is 180 degree. Is it right? 180 degree.
Yes, sir.
Suppose if I take this as some phi. Suppose if I take this as phi, no? Phi plus 90 plus theta. Phi plus 90 plus theta equal to 180. Is it right?
Yes, sir. Yes, sir.
Theta plus 90, so remaining is phi. The entire angle is 180. Wait a minute. No. So this one is theta. Actually, here it is 90 degree, right? Here, therefore, this angle is 90 minus theta. Is it right?
Yes, sir. Yes, sir.
90 minus theta. So I'll read this again. So theta, this one is theta, and here it is 90 degree, therefore it is 90 minus theta, and here it is 90. Okay, 90, which means it is theta, right? This one is so 90 minus theta. So what about this remaining portion? This is theta, right?
Yes, sir.
Theta. Therefore, this one is again 90 minus theta.
Minus theta.
90 minus theta. Therefore, sine 90 minus theta. What is sine 90 minus theta? So here
Sir,
the angle
cos
is
theta.
90 minus theta. Therefore, sine 90 minus theta is opposite by hypotenuse. R divided by hypotenuse, which is equal to R. So therefore, cos theta equal to R divided by small r, capital R. Here R it is hypotenuse. So we know it is a right angle triangle. Again, it is right angle triangle, bigger triangle. Okay, R square plus X square. So root of R square plus X square. So R is equal to R square plus X square. Therefore, 0 to 2 pi R, mu naught by 4 pi I dl. Here instead of R square, you go for R square plus X square. R square plus X square. And cos theta, it is R divided by R square plus X square
Root.
inside the square root. So this is the total magnetic field. Now you just integrate. So integration, it is very simple here because the only variable is dl. So other than dl, all the quantities are constants.
Yes, sir.
Okay, just take all the constants outside. Mu naught divided by 4 pi R divided by IR divided by, so you just multiply this one, R square plus X square power 3 by 2. So this one becomes, because a into root a, you can write this as a power 3 by 2. So that's that identity we used here. So 0 to 2 pi r and dl. So if you integrate dl, you will get L. So limit is 0 to 2 pi r. So the answer is 2 pi r. Okay, so the entire integration B equals to mu naught by 4 pi I into R divided by R square plus X square power 3 by 2. It is 2 pi R. Okay, so cancel pi and 2, R becomes R square. Therefore, the magnetic field on the axis, along the axis of the circular coil, it is mu naught I di R square divided by 2 R square plus X square power 3 by 2. So this is the answer. You just memorize this equation.
Okay, sir.
You memorize this one. Okay, in case X equals to 0. Okay, and X is equal to 0, it means at this particular point, here it is X equal to 0. What is the magnetic field? We put the value X equal to 0. B becomes mu naught I. So here it becomes R to the power 3. And in the numerator, you have R squared. Therefore, it is mu naught by 2R. The value becomes mu naught I by 2R.
Yes,
You
sir.
understand?
Yes, sir.
Okay, just memorize both the formula. Okay, at the center it is axis. So both the formulas are very, very important. The magnetic field at the center of the coil. Yeah, we have a circular coil. And current, it is flowing in this direction. Okay, and clockwise direction. Okay, at the center, exact center, what is the magnetic field we are going to find? The center O, the magnetic field we are going to find. Okay, for this case, you just take a small current element DL here. Okay, due to the current carried by the small current element, we are going to find the magnetic field at the center. Okay, you just use your right hand curl rule. Okay, right hand curl rule. If we hold the current carrying wire in our right hand, the thumb represents the direction of current. Okay, using right hand curl rule. Curl rule. The thumb represents direction of current. Right? And the curled fingers. They represent the direction of magnetic field. So in this case, if you see using your right hand, the magnetic field will go into the plane of paper. Okay, it is inside.
Yes.
Into the plane of paper. Okay, now we are going to derive the equation. See, this is the distance between the current element and the point where we are going to find the magnetic field. So at O, we are going to find dB. Okay, therefore, using Biot-Savart law, dB equals to, at a distance, you just take this as small r vector, dB equal to mu naught by 4 pi I dl sin theta divided by r square. Okay, here theta, for this kind of cases, no, the theta angle between the current element and the radius vector, it is always 90 degree. The theta is 90 degree always. For this particular case, it is not applicable for all the cases. For this particular circular coil, at the center, value theta is 90 degree.
Okay, sir.
Okay, it means that DL is perpendicular to R vector. Therefore, sin theta becomes 1. Sin theta becomes 1, and we are going to find the total magnetic field. Total magnetic field here, it is integral dB. Integral dB, which is equal to integral mu naught by 4 pi I dl divided by r square. See, in this case, you just take the value, otherwise the segment dl anywhere. If you keep dl anywhere, the distance between the center and the dl is always same. It remains constant.
Yes, sir.
R remains same. Then current is also constant. Okay, except dl, all the terms are constant. Okay, just take them outside of the integration. So mu naught I divided by 4 pi, they are constants. So similarly, r square also constant. So only integral dl is the variable. So it means that we are integrating the loop over its length. Therefore, integral dl is equal to 2 pi r here. It is the circumference.
Yes, sir.
Therefore, the answer is mu naught I divided by 4 pi r square into 2 pi r. So cancel the terms, pi cancelled, square and r cancelled, and 2 alone remains. So mu naught I divided by 2r. The answer will be. So here in this case, except dl, all the terms are constants. But in the previous case, it is entirely different. Okay, we have to solve all those things. Okay, the value theta, in that particular case, theta is 90 degree, but we had something called the vector resolution. That process we discussed.
Yes, sir.
Okay, this one, it is not needed. Okay, so this is the answer. Sometimes they ask in 2 mark question. Suppose if you have n number of coils,
2 pi.
for n coils, V becomes mu naught n I divided by 2r. So the n will be multiplied along with I.
Okay, sir.
And we have graph for axis for the magnetic field at its axis. The formula we know, it is mu naught I a square
R square plus x.
Yes, 2 r square plus x square power 3 by 2.
3 by 2.
Here r is radius. Okay, the graph is between the distance x and b. X and b, you can go for both the distance, x and minus x. Because the circular coil, it is
wound like this. Okay, either you can go in the right side direction or in the left side direction. So this one is positive x and this one is negative x. Okay, whatever it may be, the value x square is positive. Okay, x square, because x is, even if it is negative, x square will be positive. Therefore, for positive x value, see in this case, if x equals to 0, b is not equal to 0, b you have a separate value. Because we know at center, mu naught I divided by 2r. Okay, at center it is mu naught I by 2r. Therefore, when x equals to 0, we have the value. Magnetic field, we have non-zero value. Okay, as you go along the x-axis, what happens now? It is decreasing. Okay, it is in the order of power 3. Because r square plus x square, power 3 by 2, right?
Yes, sir.
Okay, if you plot using any random values, okay, for mu naught I r square, capital R square, you just insert some random value. And if you plot a graph like this, no, b is inversely proportional to some r square plus x square power 3 by 2. Okay, it is similar to power 3 by 2. Okay, with respect to distance, it will decrease. It will decrease. So therefore the graph will be looking like this. At infinity, it becomes 0.
Okay, sir.
Similarly, in the left side, if you increase the value in the negative x-axis, so you'll get a same identical curve in the reverse side also. Okay. For semicircular coil, semicircular coils, consider you have a semicircular coil kept like this. Okay, and a coil with radius capital R. See, the current is flowing in this direction. Okay, at this point P, what will be the total magnetic field? See, we have 3 segments of wires. Okay, consider 1, 2, and 3. The 3 wires carrying current I. What about the total magnetic field due to the all the entire wire at the point P? See, in this particular case, the line dotted line, it is parallel to the wire segment 1 and 3.
Yes,
So
sir.
for these 2 cases, theta is 0.
Yes, sir.
Theta is 0.
0.
Therefore, their magnetic field is 0 at this point. Okay, only if you have any angle theta, there will be some magnetic field at this point P. Otherwise, if theta is 0, automatically the value magnetic field will become 0. Therefore, the magnetic field at the point P, it is only due to the semicircular point segment,
Okay,
this semicircular segment only. Therefore, for this case, the value will become BC divided by 2. Why it becomes BC divided by 2? Only half of the circle is available. So remaining
yes.
half is not available. Therefore, the value BC is mu naught I by 2R.
Mu naught
Mu
I by
naught
R.
I by, no R, it is 4 4R.
4
Yeah, be careful. Mu naught I by 4R. Okay. And we
Yes.
have a common case. Common case, you see, for this question, sometimes they give See, this is the center. Okay, and what happens now? Now you have current carrying wires like this. Okay, now it is point B. What is the magnetic field due to this circular coil? See, but the circular coil, it is not fully complete. Okay, only the portion is there, and then remaining part is missing. For a full circle, the angle is
360.
2 pi. 2 pi, yeah, 360. So what we are going to find now, 2 pi minus theta, which is equal to the arc length divided by the radius. So what we need is the arc length. Okay, that is one full arc, it is 2 pi r. For this case, we don't know exactly. So the arc length is the radius times, suppose if it is r, 2 pi minus theta. 2 pi minus theta. Okay, suppose you just take this arc length as capital small l, length. Therefore, our magnetic field, which is equal to mu naught by 4 pi IL divided by r square. Okay, IL divided by r square. So this is the formula. Now check this with this case. Check the same with the previous case.
Okay, sir.
For semicircular coil, the value theta is 90 pi. For
Yes,
this
sir.
case, theta is equal to pi. Therefore, the value L is equal to 2 pi minus pi into
Into
r.
R.
Therefore, pi r. We got the answer, right?
Yes, sir.
Pi r. The value B equal to mu naught by 4 pi into r square into pi r. So pi cancel, r square cancel, mu naught by mu naught I. So I we have to include. I
Unit I by
divided by
4R.
4r we got. So therefore the answer is correct. Okay, so you just remember this formula. So just take 2 pi minus pi. 2 pi minus theta.
So this is for any case, right, sir?
Yeah, any angle. So angle if it is 30 degree, 60 degree, whatever it may be, you just use this formula.
Yes, sir.